Hello, welcome to 6.5, which deals with dividing monomials. And it's also kind of a little bit of an introduction to some of the property of exponents. We're not going to give it all away, but some of them. So let's get into it. So let's look at the properties of exponents for multiplication. So if you recall, when you have two monomials that have like-based, they have the same base, a, and different exponents, and you're multiplying, when you multiply them together, you add the exponents. Then if you raise an exponent to another exponent, power to a power, you multiply. Then if you raise a product to an exponent, that means that you basically distribute that exponent to both the both factors in that product. And then finally, equivalent fractions property will be used, so that when you have a fraction, you can multiply top and bottom by the same number and they're equivalent, and vice versa. You can take something that is a product of, two numbers where over two other numbers or letters, but if you have the same factor, you can cancel out and you're left with the original, right? So let's go ahead and look at quotient property. Now, the book describes this in splits the quotient property in two ways, whether the numerator has the greater number of exponents and the denominator or the denominator. So essentially, if multiplication means to add, to divide, when you find the quotient, you're subtracting exponents. Either way, you're subtracting. And the way that this property goes is if the larger one, wherever the larger one is, that's where the difference goes, which kind of makes sense if you think about it. You can think about it that way. That's fine. So if you have x to the 9th, what that actually means is that you have 9 x's, yeah? This is a lot of x's. 1, 2, 3 more. One more here. So you have a total of 9 x's over 7 of them. 3, 4, 5, 6, 7. So you can see shorthand helps us, right? These will cancel out. And you're left with 2 of them in the numerator. So your answer would be x squared. Okay, so x to the 9th over x 7th. So it's the same as saying top minus bottom, right? 9 minus 7, x squared. Now, if you have here, so then for this one, we would do 10 minus 2, which is 3 to the power 8. Okay, let's do a couple of examples. So let's say you have here x to the 15th over x to the power 10. That would be x to the power 15 minus 10, which is x to the power 5, or x to the 5th power. That's for A. And then for B, 6 to the 14th power over 6 to the 5th power would be 14 minus 5. So that would be just 6 to the 9th power. Okay. Now, what if the denominator has more? So technically, we haven't introduced negative exponents. That's the next section. But for now, we can say, look at this. So we have 8 b's here. 5, 6, 7, 8. They're all being multiplied. That's what exponentiation is, repeated multiplication. And then on the denominator, you have 12. Okay, so basically, if you find the difference between 8 and 12, 12 minus 8, that would be 4, right? So notice, where is your solution? So if I was to cancel these out, I'm left with 4 b's in the denominator. So basically, it's 1 over b to the power 4. So the way the book defines it is just to subtract greatest minus the smaller, and then if the larger exponent is in the denominator, your answer is in the denominator. And if the larger exponent is in the numerator, your answer is in the numerator. So for B, you have 7 cubed over 7 to the power 5. Well, that would just be 1 over 7 to the 5 minus 3, which is 7 squared. So 1 over 7 squared, which is 1 over 49. That wasn't too hard to multiply, so we left it. Okay, so that's that. And then 0 exponent if you have anything raised to the 0 power, then it's equal to 1. And this can come from the exponent rule, right? The quotient rule. So if you have a number over itself, and if you were subtracting the exponents, you would get 1 minus 1, which is x to the power 0, which is equal to 1. So any number raised to the power 0 that's non-zero, it's equal to 1. So let's say here, a, 9 to the 0 power is just 1. B, n to the 0 power is 1. A, 5b to the 0 power, that's just 1 because it's in parentheses. And similarly, b, negative 4a squared b to the 0 power is also 1 because it's inside parentheses. So it means, hey, take all of this and raise it to the 0 power. So that's just 1. Okay. Now, what if you have a quotient that's raised to a power? That just means you can distribute this to top and bottom. So let's say, for example, here, 3/7 raised to the power 2 can be rewritten as 3 squared over 7 squared, which is 9 over 49. Okay, so B, you have B over 3 raised to the power 4. So then that simplifies to become B to the power 4, 3 to the power 4, which is just B to the power 4 over 81. Okay, and then C, we have K over J raised to the power 3. Well, that's just K cubed over J cubed. Okay. All right, so in summary, we have, if you're multiplying them, you add the exponents, same base. If you're raising a power to a power, you're multiplying the exponents. Here, product to a power, distributing. Quotient, you subtract the exponents, but if it's depending on where the greater number is, if the greater number is in the numerator, the greater exponent, sorry, the larger exponent, then you leave it like that, top minus bottom. And if it's the greater number is in the denominator, then you would do bottom minus top, but leave it as a fraction where it's in the denominator. And then anything to 0 power is 1, and then quotient to a power, you can distribute that. Okay, so let's use these rules. Remember PEMDAS, right? So, okay, so here we would simplify. This would be m to the power 20, 5 times 4 is 20, over m to the power 7. So that's going to reduce to m to the power 20 minus 7, which is just m to the 13th power. Not too bad. How about here, n to the 12th power over n to the 3 to the 4th, that's just 12. So then this becomes n to the 0 power, which is just 1. Okay, or you can even skip the 0 part and just go, oh, okay, this cancels out. That's equal to 1. Anything over itself is equal to 1. Okay, so then here, y to the 9 times 2 is y to the 18th power. Oh, wait, sorry. Let's do this a different way. Let's do inside the parentheses first, since these are both y's. Y to the 9th over y to the 4th is y to the 9 minus 4th power, because it's a quotient. So that's equal to y to the 5th power and then squared. So 5 to the power 2 is just y to the 10th. Could we have done it the other way where we used distribute the 2 and then subtracted? Yes, you could have. All right. So here, there's nothing to simplify. So let's go ahead and raise everything to the 4th power. So this is going to be 2 to the 4th power, m squared to the 4th power, over 5 to the 4th power, n to the 4th power. So 2 to the 4th power, 16. M squared to the 4th is m to the power 8 over, and then 5 to the 4th power is a large number. I'll just leave it like that. And then n to the 4th. Okay. All right. Let's do this next one. We have x 3 times 4. So that's x to the power 12 times x to the power 2 raised to the power 5. That's going to be x to the power 10. Over, and then this is x to the 6 times 5. That's x to the 30th power. So simplifying the top, 12 plus 10 is going to be 22, right? You add the exponents when you're multiplying, same base, okay? Over x to the power 30. So then that's going to be 1 over x to the power larger minus the smaller. 30 minus 22, which is 1 over x to the power 8. All right, all right. Let's do another quotient here. Let's see, can we reduce, what number divides into 16 and 24? How about 8? So if I take this, divide top and bottom by 8, I get 2, right, over 3, 2/3. Then the a's, so let me just write the rest of it. A to the power 7, b to the power 6, b to the power 8. So then it's going to be 2/3, but here it's top minus bottom because it's 7 minus 1, so it's going to stay at the top. A to the power 7 minus 1 is 6, so that takes care of this. And then here I have 8 minus 6 is 2, but it's the larger one is in the denominator, so that's going to be b squared. All right. Let's do one more. Find the quotient. So first we would multiply these two, the numerator, and then simplify the denominator. So on the top, 5 times 6 is 30. X squared times x cubed, that's going to be x to the power 5. 2 plus 3 is 5. Y cubed times y squared is going to give me y to the power 5, right? Multiplying, I'm adding the exponents. That's all over 3x to the power 4, y to the power 5. Well, 3 goes into 30 10 times, right? That simplifies to become 10. X to the 5th over x to the 4th. So x to the power 5 minus 4 is just 1. And then these 5, these will cancel out. So your answer is just 10x. That's nice. So that's it for 6.5. Good luck. There's your homework, and happy studying. I will see you on the next video.